Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about anonymous types. This allows you to essentially create a completely brand new custom type on the fly without having to first declare it. Okay, so here let's learn about anonymous types. Let's say, for example, we want to define some kind of type that will hold a string for a name and an int for an ID. And one way to achieve that is obviously by defining a normal type. So we can do a public class, call it player, then inside define a string for some kind of player name, and then int for some kind of ID. Then up here we can construct something of new player, and then assign whatever that we want. And if that's it, this works. We define the type and then we use it. This is what you should do if this type is something that is widely used, something that you use in a lot of places. But what if, for example, you just need this type, you just need to organize this data just in a single place? What if it's used in just one tiny use case? What if you really just want to organize some data? If so, then for something super quick is instead of defining a normal type like this one, instead of that, you can just use an anonymous type. So let's not define this. And instead, for defining an anonymous type, first we write the keyword new, and then we don't write any type name, nothing like that, nope. Instead, we just open the curly braces right away, so just like a normal object initializer. And now here we can define whatever properties we want with whatever data we want. So for example, let's say name equals CodeMonkey, and ID equals 1. And yep, just like this, here we have our perfectly valid anonymous type. Then we can assign it to something. We can assign it to some kind of variable. But since this type has no name, we can't really write a name for the type. We can't write int or something like that. We can't write a type name because no type name exists. What we can do is simply use var. So var and then the name, let's say player data equals this. And yep, here we have our type. And if we mouse over player data, we can see, yep, here Visual Studio is telling us that this is an anonymous type. And inside it, we have a string for name and an int for an ID. We can also do a log on this in C. So console, let's write line. And if there it is, name CodeMonkey, ID equals 1. So here we have constructed our anonymous type with our data. Then we can also access it, so we can go inside player data. And over here, yep, we can see autocomplete already shows us everything inside of this type. So it has the default functions that every single type in C# has. So get type, hashcode equals into string. All C# objects, all C# types have these functions. And then it has the two specific properties that we just defined, name and ID. Now also, one very important thing about anonymous types is they are read-only. They are immutable types, meaning that we can read data, so we can access the name, we can print this, we can read it, but we cannot modify it. If we try modifying, nope, we have an error. It is telling us that the property name cannot be assigned to, it is read-only. We have this error because this is a property and it's a property with just a get defined. Also importantly, they are properties, they are not fields. That is why I named them in this way, using Pascal case instead of camel case. That is because anonymous types, the data that they store it inside properties and not fields. So anonymous types are really meant for read-only use cases. Like for example, you just want to organize some data in some nice structure. And if your goal is just organization, then you probably do want read-only, so this is perfect. If you want something with read and write access, then you should probably define a normal type, or a tuple, which is something somewhat related that we're going to cover in the next lecture. So essentially, anonymous types, those are all based on inference during compile time. You already know how var, this is a compile time feature. During compilation, the compiler looks at the variable. It looks at what var is being assigned to and use that to set the type. So if we do var I equals some number, if we do this, then when the compiler goes to define the type for I, it looks and sees what is being assigned to it. In this case, it's a whole number, so it defines I as being an int. And it's really the exact same thing over here for the anonymous types. The compiler infers the type for each of these properties based on the value assigned to them. So that's why this one is an int, this one is a string. And then the compiler constructs a brand new entire type just to store this data. So literally the compiler in the background is storing something like what we had previously. So something like a class, player data, with a public string name. And this one is a property with just a get no set, and a public string ID with again also just a get no set. So when we do this, the compiler is auto-generating a type just like this one. And then it assigns that type, that instance of that type, assigns it over here to the player data. Now we can actually see the type for this. We can go inside player data and call the get type. Again, the standard function that every single type has. Let's do a console.writeLine on this one to see. And if there it is, we can see this one is of type, anonymous type. And inside has two parameters. It has a string and an int. So this is the type. It's an actual type. It's a normal type, just like any class, any struct. But it's simply auto-generated during compilation. Now this is quite different to what we covered in a previous lecture, the one on dynamic. When you make something dynamic, this one is all based on runtime data. Meaning during compilation, it does not run any checks, it does not create any types. Meaning it does not validate any data at compile time. So over here we can access name, which does exist, but we can also access something that does not exist. Again, because dynamic is only handled at runtime. Whereas var and anonymous types, this is handled during compile time. And if so, over here we have validation, and we know, okay, this type does not have anything called test. So if you ever get confused about anonymous types, do remember this part. It helps a lot in understanding how they work. If you look at it from the point of view of the compiler looks at this data and uses that data to infer and create types. So for the data inside the anonymous type, this can be anything you want, as long as the compiler can infer the type. So for example, you cannot define here something as null. This does not work, this is an error. It is an error because null can be anything, it can be pretty much any type. So just like this compiler has no idea what type to make this name, but we can, for example, define a class, a normal class, and then up here do something like this. And yep, now this does work. Another thing we can do is put anonymous types inside other anonymous types. So over here, let's define a type, let's call it message, and we do a new anonymous type, and just say something like message. Yep, so here we have our nice anonymous type, and then inside player data, we can also add that. So we can add message equals our message anonymous type. And then through this one, we can access message, and inside we have the actual message. Also, instead of writing message equals message, if you're defining a new anonymous type with something that is already stored in a variable, you can just write that variable. And doing this, it will essentially name this property with the exact same name as this variable. So if we go inside player data, we can see, yep, we do have a message there. So when using other data to create data inside our anonymous type, we can just pass in the variable that stores that data and we don't have to give a specific name. Then, like I said, anonymous types are read-only, meaning you cannot create and modify it. So over here, player data, set the name equals something. Nope, this does not work, this has an error. But what we can do is use a with expression. We can use that to create a new type based on another one. So for example, we can construct a new player data. Okay, great. And then we construct a new one. So var player data 2. And for this one, we can base it on the original player data based on that one. And then we write the keyword with, and then we can open and close the curly braces and modify some data. So let's say name equals Iron Man. And yep, just like this. So basically this is going to start with the data inside of player data and then applies an override to the name. So here, if we do a console.write line on both these, so on player data 1 and player data 2, if there it is, so the first one is CodeMonkey idea 1 with message, and the second one has the same ID, the same message, but a different name. However, importantly, we did not modify the original anonymous type. We did not modify that one. That one is still read-only. We simply construct a brand new one based on a previous one. So here we can define an anonymous type with really whatever data we want. And then we can also define an array of anonymous types. So to create a new array, we do new, and then again, it's an anonymous array, so we don't define any type. Instead, just open and close the square brackets, then open and close the curly braces to initialize our array. And now here we can define our anonymous types. So let's do one. Let's say something like name equals something. Yep, just like this. And again, we can assign this to a player data array, just like this. And yep, here we have an array of anonymous types, and it has 4 elements, 4 with all of this data. Now, one very important thing is the anonymous types here, they have to have the exact same format, the exact same properties. If we add a different property, let's say an ID to just one of these, if we do, then this one does throw an error. So it has to have the exact same properties. And it's also important that they are in the exact same order. So if we have the exact same ones, but are in a different order like this, nope, we still have an error. Again, that's because of what I mentioned, how the compiler is creating an actual type based on this data. And if we have one with a different format, then it needs a brand new type, and the compiler does not let us create an array using multiple different types. By the way, actually, there's one exception to that. If we make this an object array, if so, then yep, now this one does work. Object is the base class for every C# object, every C# type. So if you make an object array, you can indeed store literally anything in there. I covered something like this in the lecture on data boxing. By doing this, we can store multiple object types, and we can see there are multiple object types if we, for example, put the cursor on it, and here Visual Studio automatically highlights the exact same properties on the exact same type, and note how these 3 are highlighted, but this one is not. That is because this one is a completely separate type from these 3. So when making arrays of anonymous types, do make sure they all have the exact same structure in the exact same order, so just like this. Now, one use case where anonymous types are very useful is when doing LINQ queries. I already covered LINQ in detail in a previous lecture. Essentially, LINQ is a way to do operations on collections of data, similar to how you do queries on a database. So here, for example, we have our player data array. Now let's say we just want to get the players just on the red team. So for that, we can do some simple LINQ to get that query. So let's go inside the player data array. And this one, let's call where to write a condition. And for the condition, we're going to have a player data. And we want to select just ones on the red team. So let's go inside player data and select the team equals red. Okay, so we do a query for where the player data team is red. And then let's just call select in order to select some elements. We're going to get the player data. And it's over here that we can construct a brand new anonymous type. Let's say that after getting the red team players, we just want to keep the name. We no longer care about the theme. So here we can construct a brand new anonymous type, and you set the name equals the playerData.name. Or again, the same thing that we saw previously, literally just put it playerData.name. And yep, this constructs the anonymous type, and over here, just make sure this one is a lambda expression. Okay, so yep, so just like this, we can put the resulting thing inside of our, let's call it the red team array, and then we can cycle through it. So let's go for each var red team in the red team array. Let's do a console.writeLine, go inside the red team and just grab the name. Okay, let's see. And if there it is, CodeMonkey and Black Widow, which are indeed red team and red team. So yep, here we are cycling through some data, and for the selection, we are constructing a brand new anonymous type that holds just the data that we want. Importantly is how this code is actually quite readable, and we were able to do this without having to construct a brand new different type just to store the player name. If we had created a brand new type just for this one use case, if so, that would clutter our project, since this new type would only really be used here just in this one function. So with this anonymous type, it works perfectly for this use case without adding any clutter to our project. Now, like I said the words on this use case, anonymous types are excellent, so you should definitely use them where they make sense, but you shouldn't use anonymous types for literally everything. The rules they have actually make it perfectly clear how they are meant to be used. So first, remember how they are read-only, so you are only meant to use them as a way to organize some data temporarily, not something like long-term storage. They also cannot have any functions or events, just read-only properties. Then, since they are meant for small temporary use cases, you cannot store the anonymous type in a field, you cannot pass it on to a separate function. Although I should say, technically you can actually do that. If we make here a public static void test, and up here for the parameters, we receive something of type object. And again, object is literally anything, any type extends from object, so we can call test, pass in the player data, and this does compile. But again, this one really completely defeats the purpose, because right now we have no concept of what data is inside this object. So technically you can do this, but you definitely shouldn't. All the rules of the anonymous types, they are there for a reason. If you ever find yourself running into the limits of all those rules, then that's probably a sign that you should be using a normal type instead. Anonymous types are absolutely excellent for exactly what they're meant for. Small, simple data structures for organization. That's it. For pretty much anything else, just define a normal type. Now, one feature of C# that is quite similar to anonymous types are tuples. They also allow you to create types with no previous definition. They also allow you to organize and structure some data. We're actually going to learn about tuples in the next lecture, as well as a rough guide for when to use tuples and when to use anonymous types, and what exactly are the differences between them. Alright, so here we learned about anonymous types. This is how you can easily organize some data in a proper structure without having to first define a normal type. This can be faster and more readable. And the specific rules that you must follow, those ensure you only use anonymous types in the way they're actually meant to be used.